Hi, everyone, and thank you for joining us today for our Generative AI with Google Cloud event focused on operationalizing PaLM 2 with LangChain. My name is Lauren, and I'm the content manager for the Google Cloud community, and I'm thrilled to be here today with Guru and Gopala, who will be taking you through the content and answering your questions today. Before handing it over to the team, I just want to remind everyone that questions are encouraged, so please feel free to use the YouTube chat box, and we'll be sure to get to your questions either in the chat or at the end of the presentation. We'd also love to hear from you if you're working on any projects, where you're tuning in from, so don't be shy, please use that chat, and we'd love to hear from you. We also had a few pre-submitted questions that we'll cover as well. All right, and for any questions that we don't get to, you can always use the Google Cloud community. That's where you can engage with each other, your peers, Googlers in two-way discussion forums, and you can also find out about upcoming events like this one. And the link to the community is in the YouTube description. All right, with that, I know we have a lot to cover today, so I will hand it over to the team to kick us off.
Thank you, Lauren. Good evening, good morning, or good afternoon, wherever you're calling in from. Thank you for joining this session. Let me first start off with a quick introduction. My name is Guru Rangavital, and I'm a transformation tech lead within Google. I help customers, leverage the power of Google Cloud to optimize their businesses and expand their customer experience. I'll now turn it over to Gopala for an intro, and then we'll get started.
Hey folks, I'm Gopala. I work as an AI engineer. I've been in this journey of creating amazing generative AI solutions and AI solutions in general for Google Cloud and its strategic customers. I'm really excited for this session today and really excited to take all your questions and hopefully answer them appropriately.
Thank you, Gopala. Today we have an interesting topic. We want to cover operationalizing PaLM 2 with LangChain. And so the agenda for the day is really an overview about Google's Cloud AI portfolio. We want to get into the details of LLM-based application design. LLMs have conquered our imagination in the recent past, and our entire thought process around application design is undergoing significant changes. And then we'll get into what is LangChain, an introduction about LangChain. We'll get into some of the concepts that are involved in using LangChain. And then we'll run through a few demos. We'll build a simple generative app today. And then we'll also expand on that, build an app with memory today. And then eventually move on to, a lot more complicated app called, GenApp with Retrieval augmentation. And then towards the end, we'll, get into some Q&A as well. So with that, let's move on to the next. So I want to start off with a quick introduction about Google's, portfolio. Google has been a pioneer in the space of generative AI. Back in the year 2017, Google launched the Transformer model, which has really kind of taken off in multiple ways. And Google released the BERT model, open source the BERT model as well. And then Google has launched a number of other models subsequently as well. And very recently, Google launched the PaLM model, and that has been kind of an anchor model for many of our products at this time, the consumer-facing model, which is BARD, as well as our enterprise models as well. So what you see here are three key foundational models, the PaLM model, which has got the text version as well as the chat version, the Cody model, which is a code-based model, and then the ImageN, which focuses on image-based responses and queries against those images. Besides that, Google also has launched a model for embeddings, and we'll talk about some of the types of models as well. And we also have a sound-based model called as Chirp, and it's also coming up with newer models, down the road. Now, what you see here is the foundational model is actually powering some of our consumer experiences, the BARD, and some of you might have also been using Maker Suite. So the Maker Suite product is really focused on the hobbyist, and the BARD is really generally available to everybody to start using the power of LLM. On the enterprise side, we have a couple of key experiences. We have Duet AI, which really enables conversations, workspaces, and chat groups. The Duet AI is available for people who use Google Workspace. Google Cloud, of course, is a foundational platform on which many of these experiences can be built. On the AI builder experience side, we have what is called as a Vertex AI, and we've also released very focused models which are either focused on medical terminologies, medical documents. It's called the MedPalm. And from a security perspective, we have a foundational model called as SecPalm, which is also available for AI builders who want to build experiences in that space. Also, for the AI builders, we have the Palms API model. Some of you might have used the text bison. The text bison 001. The animal that you see here, bison, really indicates the size of the model. Let's say if you have a smaller model, like a gecko model, which is a very small size, but on the other end of the spectrum, if you are using the bison or unicorn model, you're really talking billions of parameters. That is the foundational element for this foundational model. And the numbers there indicate how the stability of the model, in the sense that 001, 002, these models are not going to be modified. So let's say if you're building a production-based production system on 001, you can expect that 001 is going to stay the same. 002 is the next revision of that model. That's also going to remain the same. But if you come across a text bison latest, a revision might happen against that, depending upon when a new revision comes up. So that's a quick overview about the different models that we have. Let's move on and talk about our cloud AI portfolio. Google has, at the very foundation of all of this is the compute and infrastructure that's available on Google Cloud. So we have GPUs, we have TPUs that is really powering all of the Vertex AI models, all the experiences that our enterprises and developers are building. That's really providing that secure, safe layer on which all these experiences can be built. On top of which is the Vertex AI platform. The Vertex AI platform could be used by developers, practitioners. At the very base, the Vertex AI platform has Model Garden. What Model Garden allows you to do is allows you to discover models. There are some models which are Google's own model, like the PaLM models, which are available for developers to start using and building applications. Besides Google's own models, we also have a number of open source models, models like Llama, and all those models are available for developers to start, experimenting and start using those models. We have also brought some partner models, so there are over 150 plus models available on the Model Garden that you can start using and start building your AI experiences. These Model Garden provides these models, and then the AI platform really provides you the foundation where you can use the tools, whether it is in terms of building connectors for external data, whether you want to expose a trained model or even a foundational model, through APIs, through extensions, and you can start tuning, you can start distilling and evaluating some of these models that you are building, so that you can improve on the experiences that you are offering to your consumers. Sitting on top of the AI platform, we have two core pillars of applications that are powering our experiences. One is called the Vertex AI Search, and the second is called as the Vertex AI Conversation. The Vertex AI Search is just like a Google search on a corpus of documents that is really very focused on your domain or your enterprise. And you could run, you could build an app on top of Vertex AI Search and start using it on your website or on an app, however you want to serve it to your customers. The Vertex AI Conversation really allows you to build intelligent agents that could be powered by knowledge from your enterprise, and that could also power experiences that you can build. On top of it all, if you want to completely go low code, no code, take out of the box experiences, we have solutions like the contact center AI. We also have document AI solutions that can be used and that can be powering some of your enterprise experiences as well. About all of this, this really provides you a very good foundation on which you can start building experiences. If you want to build very domain-specific applications like a contract analytics or something like a supply chain bot, you could start building it, and that will be very relevant for your business users. And so we have available tools that can be used by practitioners, AI developers, as well as business users can start using these experiences. Powering all of this is Google's Responsible AI framework. The Responsible AI framework helps you to set the guardrails around the experiences that you want to provide to your customers, whether in terms of the toxicity or whether it is in terms of the safety of the language that is being used. All of that can be assessed, and then you can evaluate. You can put some guardrails around the language that is coming in, as well as you can tune your language that you want to share with your customers, whether it's using your brand language or however you want it to be. The Responsible AI framework provides you that capability as well. So that's a quick overview about Cloud AI portfolio. Let's turn it over to a typical usage of LLMs. As we think about applications that are being powered by a large language model, and as we think about building orchestration of the power of the LLM along with various other capabilities that are available today, like a Google search or your database that is on-prem, how do we want to use it? The typical usage of LLMs today is a simple API call. You could be making an API call, getting a response, and then you may be interacting with that large language model. And the typical use cases could be like, I want to classify this, or I want to summarize this text, or I want to ask a simple Q&A. But if you want to expand the capabilities of the large language model beyond just a question of responding to a simple sequence with a new string, you want to really bring in the power of some of these frameworks like LangChain, and that's what we want to go into some greater detail today. And what I'm sharing here is a simple example of a question that I posed. Today happens to be a game day between India and New Zealand. We have a World Cup cricket going on. I was asking the large language model, who is going to win the World Cup for 2023. The large language model, is trained by a corpus that goes until February of this year. So it obviously doesn't have enough information about what's happening today and who has won yesterday. And so it provides a very generic response. Let's say if you want to augment the response that you're seeing in large language model, that's where you want to use tools like LangChain to be able to do a Google search, get the most current information, factor it into your response, then provide a lot more contextual response to your end users. So let's turn over to a common pattern that we see here. So the typical patterns where we see LLMs being used are, firstly, an LLM could be using a database. You could be running a SQL query on a database, pulling information from the SQL query, publishing it to your end user. Or you could be running a Python code, get a response from the code and responding to it. You could be running a Google search, as I was just talking about, or you could be doing a webhook. You could be running an API against a web service, getting that information, factoring it into your response, and then publishing it back. So to orchestrate all of this, you really need a set of tools, and you don't want to reinvent the tools. And that's where frameworks like LangChain become super convenient for developers. The second pattern that we see in application development is where you have multiple specialized large language models doing multiple activities, and they all feed their response to a synthesizing large language model, which might take these individual responses, putting it all holistically and publishing it to the to your end user. So that's also a common usage pattern that we have seen. Another pattern is where you have a chain of LLMs, large language models, coupled together, and that really provides you a very nice way of structuring your response. And if you have come across it's like React. React is a common framework that's being used where it is you have one LLM which will be doing reasoning, one LLM which will be doing like observations and fact checking, and one LLM which will actually be collecting all of this, synthesizing it, and publishing it. So you have large language models completely revolutionizing how we want to think about applications. So I think we have a very bright future with LLMs, and I'll now turn it over to Gopala to talk to us about LangChain and how LangChain can be integrated with large language models.
Thanks a lot, Guru. That was really informative. Yeah, and I'd like to talk about LangChain. First of all, what is LangChain? LangChain is an open source library that works at the moment for Python as well as TypeScript. Why are we interested in this? Well, all the things that Guru just discussed a while back, those are APIs, those are models. Those are great as a foundational step. In fact, Google calls most of those models that we build, we call them as foundational models. However, when you want to go a step ahead, you want to build something, which you want to maybe put in production, or you want your teams to leverage that. You want to go the extra mile. You want to ensure that the pipeline is built end to end, and it's able to take care of not just simple tasks, but also sometimes complex and even complicated tasks, which require multiple logical flows to be traversed, right? So LangChain essentially connects the PaLM, Vertex AI PaLM, Google PaLM 2 models, Hugging Face models, or any other open source models, or for that matter of fact, any other models owned by other companies as well, to a host of different modalities. Like it can connect to Google Drive, it can connect to Google Search, the APIs, knowledge repositories, databases, and even code repositories. So you can do a lot of things. You can bring external data such as your files or other applications and API data as well to an LLM and make the most out of it. And you can also go a step further and do something even more advanced with it. You can use agents, you can build agents that allows a large language model which is sitting on a server or even deployed locally. It allows that large language model to interact with the environment which you provide, and then build and sort of control the entire flow of execution, which is very interesting. And in the coming slides, we will definitely discuss about that. But here's where LangChain comes into picture. LangChain is that sort of a framework that we can use, and it's very straightforward to use, very straightforward to write code in. Just a couple of lines of codes, and the first app, the first generative AI app that we want to build will be ready. And all that can be done in a couple of minutes, which we're going to show up in a couple of slides. So if we move to the next slide, we can see that LangChain has been growing in popularity. In fact, it's been exploding in popularity. On the right hand side, you can see the star history on the GitHub repository of LangChain. It has just shot up like anything after, I'd say, February or March. That's where people realized uh, the capabilities these large models have. Um, the large language models are not just basic tools. They're not just simple models, but they're actually quite advanced, and they can definitely be used to do a lot more stuff. Okay. So, what was the original intent behind LangChain? It was to develop large language model applications such as chatbots, generative Q&A, summarization, and even LLM agents. And right now, it is primarily on Python and TypeScript, and it's focused on composition and modularity. The code itself is very lightweight. There's no bulky imports of stuff. It's very straightforward. Anyone who has an experience of writing Python can get started with it. It really doesn't have a big entry barrier, right? Um, it basically helps the large language model become more data aware, LangChain, meaning that it can understand, it can reason, and it can even figure out in ways to make sense out of the data that it has and answer more complex and complicated questions. It can also look over and index over an entire private corpus of data. It can be a knowledge base. It can even be a code repository, or it can be a bunch of code repositories in your organization's code base. It can even be integrated with Google Search, which makes the sky is the limit with that. You can build a lot of really great applications that use the power of Google Search and the power of Google PaLM LLMs to help cater to your customers. So here are some of the few things that I've personally done with it, and I've seen my colleagues do it as well. We've built a natural language to SQL, interface with PaLM models, which can basically execute SQL queries. It can create its own SQL queries for my natural language, from English, and then also execute it on my database and give me the results. We can also use this models. It use LangChain to basically become a middleware to call the external webhooks or APIs, and we can also use it to synthesize outputs from multiple different models. And basically, I can club together Gecko model. I can club together Otter model. I can even club together Bison model. I can club together multiple models and get a more refined answer, right? So that's all cool. We came to know what LangChain is, why do we want it, um, but where does it fit in, right? So the large language model stack can sometimes be a little daunting to understand, because it has a lot of technical modalities, which are often discussed in the research world. There's things like pre-training. We have autoencoders, we have contrastive training, then there's fine tuning, which is a little more relaxed, but it still deals with unfreezing the model weights and changing stuff. And then we have prompt tuning, which is basically it's a way of making the model understand the data that you're sending it. So instead of retraining the model on the new data, you essentially conform your data in a way that the model understands it much more well. That's somewhat in between. That's where LangChain fits in. LangChain fits in the few shot and the zero shot zone of things. Few shot basically means you provide a few examples when you're sending in the prompt, and zero shot basically means you provide no examples while sending in a prompt. What these examples basically do, they ensure that your large language model has an idea about how to respond. So it's like think of it like giving a single or a couple of examples for your machine learning model to quickly learn about its surroundings and answer appropriately. Though, I mean, the few shot could be as small as two shot or three shot. Zero shot basically means you're giving no example. You're using the entire training data on which the LLM is trained on. You're directly using that to answer your questions, right? It can also be, we also have this thing. We have, let's say, data in the databases, or we have different tools. Um, we don't want to move the entire data to my large language models. For example, I do not want to train a new large language model with my data, and because it's an expensive process, and I don't really want to put in all those dollars to train a new model. So what I can instead do is that I can refine a database to store all this information, and then I can enable this large language model to connect and communicate with this database. That's the impressive part of using LangChain. Um, in the next slide, we can see all the different ways we can talk to LangChain and what are the different things. I will try to quickly explain what different things are, starting from the chains part of it. Chains is basically it's a way of stacking a bunch of applications. I'm going to call it modular code applications, stacking them together and getting some meaningful information out of it. Those could be things like question and answering, right? Things like summarization. So instead of directly summarizing a document, you can go ahead and basically ask the large language model to itself figure out what the topic is about and then summarize it accordingly. So if I'm trying to summarize let's say a document from automobile industry, it will focus more on the points which are related to, let's say, the engine capacity, the battery capacity, the displacement, the torque, and all those other things. So it is able to understand the intents much more better. It can chain together different actions and give us the output. We can also create custom chains. If I want to do custom actions in between, like if I want to do mathematical equations, I want to be able to solve equations like linear algebra and stuff. So I can create a chain that understands my intent, and converts it into an output which Python program can solve for, or any other program can solve for. That's what chains are for. Then we have agents. Agents are a little more advanced. They help you achieve a lot of great things. You basically use agents to give access of the large language model to an environment. So let's say I'm building a calculator application and I want to integrate with an agent. I would end up giving the agent the access to my calculator app. So if I ask the large language model agent in this respect, if I ask it to, hey, can you just add 5 and 10, what it's going to do is that instead of adding it itself, it's going to figure out that I'm asking it to add some things, and it's going to go ahead and talk to my calculator application and go ahead and punch those numbers. It's going to add 5 and 10 together, and it's going to get the output 15, and then it's going to tell me, hey, the output of your calculation is 50. That is just one example. You can bring, you can do complex things with it. Like personally, I've built an application which takes natural language queries and converts them into SQL, but it is also able to retain my intents in a way that even if it's not a direct query, like if I'm asking questions like a business analyst, it is still able to answer because it's able to do that complex understanding. And I give it access to run SQL queries on the database of my choice. Then we also have memory. We can basically store chat. We can use a vector database, which can help us in Q&A, sort of like retrieval augmented generation, right? We can also store chat history. We can store conversational buffer with memory, which means we have like a rotating window of conversation so that it doesn't lose context while you're interacting with it. And we also have, on the other hand, we have the other modalities that can interact with LangChain. This is more on the solutioning part of it. On the other hand is the things that it provides, the classes that it provides. We have large language models, we have chat, we have embeddings to create embedding vectors. We also have some prompt templates. Those are really useful in quickly building an app. We have output parsers for, let's say, JSON, XML, and other stuff. We also have example selectors, which help us understand our output a little better. And we can also create different types of indexes, which we're going to talk about in a couple of slides, which are text splitters. These are all methods, and these are all classes which help us solve the problem of creating, solve the problem of not having to write a lot of boilerplate code to create our first application, which uses little advanced, methodologies of large language models. Right, we have text splitters and all those things. Then we move to agents. So agents, like I talked about, it's one of my favorite things. Not just in LangChain, in general, I really like playing around with agents, because here's the core idea, right? Agents use the large language model as the reasoning engine, much like humans use their brains, and they determine how to interact with the outside world, and they give the command output to whatever they're interacting with. So agents is like, it's like a human mind. It can be, it's really great at making decisions, but the execution part is done with, let's say, can be done in an example that I gave. You can be done using a calculator app, or you can give agents access to your command line, or you can give it access to a BigQuery database or something else, right? So large language model use agents as a reasoning engine, which is in itself a really powerful way to figure out, non-deterministic sequence of actions. It's really good at that. And then, as you can see the diagram, the LLM is sort of like the heart of it, and it can basically directly interact with code. It can interact with Google search. It can interact with webhooks. It can do a lot of things, and one agent can do multiple things. So it can also be stacked together in chains, like we just saw few moments back. You can do that. And this is how you implement an agent. Again, same sort of stuff. You just give it input, ask a question to it. The agent is going to go ahead and talk to the large language model. The large language model, being the reasoning engine, it's going to give you an output. It's going to tell you, hey, return this instructions or do this. Then it's going to go ahead and talk to the tool. The tool can be, command line, SQL, whatever you want to build. So it's going to go ahead and do some executions on the tool, get some output, show it again to the LLM, and format it in a nice and crisp way, and give you the final output, right? So agents are not too hard to implement, right? We discussed them. Now let's talk about embeddings. So an embedding is just a way to represent any form of data in numbers. Numbers is really great. Machine learning models love to work with numbers. So it's a in a very high level way. It's a way to explain or represent a high dimensional data into a high dimensional data into a low dimensional space with high dimensional vectors, which basically means that you want to be able to convert one modality of one modality like text or sound into numbers, right? So how old are you? You can have one. What is your age? You can have another embeddings. So ideally, an embedding space captures some of the semantic of the input by placing semantically similar inputs close together in the embedding space. And we can see that in the next slide. Um, if you build great embeddings, semantically similar things like music, song, audio are going to be close by. And that's really important, because the application that we're going to build eventually is going to use those concepts to show you how great it can be when it's combined with a lot of other things like, let's say, LangChain and PaLM APIs, right? So, so each vector is embedded into a high-dimensional vector space, and the embedded vectors are indexed in a vector store, which we can have like a lot of them are available. And this is basically a database that is optimized for storing and searching vectors. It uses refined algorithms to quickly estimate and get you the similar vectors out. So if I say music, I'll quickly get song as an output, right? So that's about embeddings. And I think my teammate Guru here would love to show some demos, and we can get started with that.
Yeah, thank you, Gopala. So we'll get started with a quick demo. So what we are going to first build is a simple generative app, and just to get everybody started, right? Just walk through the basic steps that are involved in any generative app. And what you see here is a simple block diagram, the things that you want to keep in mind as you want to build a simple generative app. You want to first plan for installing the libraries. You want to get an authentication, whether it is your API key or OAuth or service account, whichever is your authentication mechanism. I mean, the API key is typically used for the Maker Suite PaLM API, but if you want to use Google Cloud, you want to use OAuth or service account. And the next step is initialization, and basically building any functions that are required for your app. And for a simple generative app, you won't really be building much functions, but you want to initialize the Vertex AI so that your project is recognized. Your location of the where you're running your Vertex AI is recognized. So that initialization is the second step, and then you get into building a UI. And the UI could be as simple as just a ask a question, get a response. Or if you want to build an application for your enterprise, you want to think of very simple, lightweight UI solutions like a Gradio or a Streamlit, or maybe you can even think of some other, like a JavaScript, or if you want to make it platform agnostic, think of Flutter, right? So whichever is going to be your UX platform, plan for that. And then you want to plan for some level of a prompt engineering. As Gopala mentioned, we want to plan for some kind of a prompt templates to be able to capture those questions from the end user, feed it to the large language model, providing some context, and then getting a response from the large language model. So prompt engineering is something you want to spend a little time, and then call the foundational model, get a response. And if you need to be parsing the response, let's say you get a response and you really want to take it out and really present it in a way that's a lot more user friendly, you could do some parsing and then present it back to the end user. That's going to be our kind of a plan for a simple generative app. We'll now play a quick video where we will walk you through the steps, and it should take about 5 minutes. So let's go through that. Illustrating how to run a simple generative app using PaLM 2 and LangChain. And you can access this code using the GitHub link given in the slides. Go ahead and click on the first cell, and the first cell is really installation of the libraries. We'll be installing Google Cloud AI Platform and LangChain. Go ahead and execute this. This usually takes a minute, and at the end of this, you might have to restart the runtime. You could also execute this with a -q option, which will really run this installation in a quiet mode. After that is done, we can move on to the next cell. The next execution is really authentication, and here you authenticate your ID that will be used for the entirety of the collab. Go ahead and execute this. So it does a simple OAuth authentication against your Google Cloud ID, and then that will be used for the rest. The next step is really importing the libraries, and we are going to be importing LangChain, of course. We are also going to be importing a few other libraries from LangChain, like LLM, Vertex AI, and LangChain prompts. We'll also be importing Vertex AI platform as well. Go ahead and run this cell, and so our Vertex AI version is 1.36. So the next step is initializing Vertex AI, and we are going to be using the project name and the location, and we are going to be initializing Vertex AI. So let's go ahead and run this cell. So now your location and project where you will run this is decided. After this, it's all about invoking the large language model, and we're going to be using the Vertex AI class from LangChain, and we are going to be using text bison 32k, and we will pass the parameters as shown here. This will instantiate the Vertex AI class and assign it to an object called LLM. And we'll be passing on a query to this LLM, and it's a very simple, pass the query as an argument to the LLM object, and it's going to publish a response. So the question we are asking is, who was the president of US when Justin Bieber was born? So let's go ahead and execute this, and the LLM, does its inferencing and comes up with a response, George Walker Bush. Unfortunately, this is not the right answer because when Justin Bieber was born, George W. Bush was not the president. So clearly, there is something we got to do for us to get a better response from the large language model. So we're going to be using what is called as prompt template from LangChain in order to guide the LLM to come up with a good response. So for our purpose, what we're going to do is create a template, and that template has a structure. We are going to include the question that we want to ask as part of the template formation, and then we're going to give some guidance to the LLM to think through these responses step by step. This is what is called as a chain of thought, and it really helps the LLM to really reason its response before it actually responds. And it has been shown that building structures like this really helps get a better response from the LLM. So we're going to be building this prompt template, and we're going to be passing this template to the prompt template structure, and we're going to be assigning it to an object called prompt, and we're going to be chaining the prompt and routing it to the LLM object, and we're going to be assigning that as a new object called chain, and we are going to be passing the actual question as a parameter invocation to this chain.invoke method. So then let's print the response. So hopefully we'll now get a better response. Let's see. So now for the same question, the response is different. It now says that the final answer is Bill Clinton. And the way it has come up with this response is Justin Bieber was born on March 1st, 1994. Bill Clinton was president from 1993 to 2001. Hence, the final answer is Bill Clinton, which is definitely a much better response and a correct response. So this is how you want to use LangChain with LLM so that you get better responses from the large language model. And thank you. Yeah, that was a quick demo of how to build a simple generative app. We'll now move on to the next, a little expansion of the capabilities. What we are going to demonstrate now is how to use memory. And as Gopala mentioned, memory, a foundational model wouldn't have memory on its own. You really want to augment a response from the foundational model with a memory in your application to be able to provide the context and provide the continuity as your users interact with the foundation model. So for that, we want to use something called as memory, conversation memory, and conversation chain, which the LangChain framework provides. Makes it very convenient for developers to use. As you can see in this flow chart here, the initial set of steps, installation and initialization are identical like before. What's new here is really, the yellow box, which is the memory buffer. So we are going to be capturing the memory buffer, capturing the query coming in from the user, as well as capturing the response from the foundational model, keeping it together. And then we are going to give it back to the foundational model so that the foundational model is able to keep track of the response and it's able to use it in its final response. So, so let's see a quick illustration of that. So we'll move on to the next demo, which is how to build a generative app with memory. So with that, we'll play another quick video for you. Demonstration, what we are going to do is we are going to run PaLM 2 and LangChain, but this time we are going to augment PaLM 2 with some memory from LangChain. So just like before, you can access this code base from the GitHub repo provided in the slide, and go ahead and click on that link. It's going to take you to the repo. Once you have landed on the repo, click on Run in Colab, and it's going to open this Colab environment. Once you have landed in this Colab environment, then you just need to move cell by cell and execute them one by one. So go ahead and run the first cell, and this is going to install LangChain. It's going to install the large language model. It's going to install a few other libraries like Gradio, Unstructured, Google Cloud AI Platform, all of them. Usually takes a minute, and you have to restart the runtime after the installation is done. But if in case you're running it a second time, you don't need to restart. So in my case, I've already run it once, so I don't need to restart. So the next step is authentication, and what it does is really does an OAuth authentication of the user ID, which will be used for the entirety of this code lab. So go ahead and execute that. So now you're fully authenticated, and now we can go ahead and import the libraries that are required for this code. So we'll be importing LangChain, we'll be importing the conversation buffer memory, we'll be importing Markdown, Vertex AI, the Vertex AI library coming in from LangChain itself, and a few other libraries which are required, but we may not explicitly use them in the code. Go ahead and run this. So we'll be using LangChain version 0.331. The next step is initializing Vertex AI. We're going to be passing a project code, we'll be passing a location, and we'll be initializing Vertex AI with both the project and location, and go ahead and execute this. So the Vertex AI version that we'll be using is Vertex AI 1.36.1. So now that we have initialized, now that we have all the libraries installed, we can now instantiate the large language model. We'll be using Vertex AI class from LangChain itself. We'll be passing a few parameters here, and we'll be assigning that class to the LLM object. Go ahead and execute that. So your object is also ready. The next step is really crucial for this demo, which is we are now going to define memory. And large language model does not have memory on its own, so you need to plan for some memory for it to be able to keep track of the prior conversations. So for that, we'll be using a library called conversation buffer memory coming in from LangChain, and what it does is it keeps track of conversations and it continuously appends to the prior memory. So go ahead and create this conversation buffer memory class and assign it to an object memory. We'll be passing that memory object to what is called as a conversation chain, and this conversation chain is really going to keep track of the chain of conversations that are happening. So you pass the memory, you pass a large language model to the conversation chain and attach it to an object called conversation, and go ahead and execute this. So now the conversation object is what we are going to be using for predicting the next response from the AI for each conversation. So the question that we want to ask is a simple introduction. We want to introduce ourselves to the large language model. So go ahead and provide this input for the conversation chain, the conversation object, and use conversation.predict to get a response from that large language model. So when you execute this, so what it does is it has a simple prompt template that was predefined. We use the default structure of the prompt template. You can go ahead and make some changes in the prompt template, but we took the default template for our illustration purposes. And what it does is it maintains the string of conversation, the conversation chain.
So you can see that it has retained the most recent question, and then it's asking for a response, and the AI has now responded. So now this will get appended to the prior conversation when we start invoking the conversation a second time. Let's check that out. So in this case, I'm going to pass a question. I live in Dublin, Ohio. Uh, Predict the next response. So let's invoke the conversation.predict. So it's now able to use the prior conversation along with a new question, and it's now prompting for the AI to respond, and the AI has responded. So if we now go and invoke the conversation.predict again with another question, now this will be built into the prior conversation and it's going to be used. So notice that I've mentioned I live in Dublin, Ohio. Now I want to ask which is the nearest airport for me to visit. So there's nothing in this statement for it to know where I am. But if it kind of adds up the prior conversation, it knows where I live, so it now will be able to respond to this question. So let's see if it's able to capture that. Great. So yes, so it has captured the right response. John Glenn International Airport is the nearest airport in Columbus, Ohio, which is closer to Dublin, Ohio. So I think the response is spot on. So you can see that the conversation chain has captured the prior history, and that's why the AI is able to respond with the right response. So continuing on that thread, let's go ahead and invoke a simple UI, and what this UI would do is just open up an input, output, and then you can kind of validate our earlier responses without any response on. We can validate our prior response. So here the question I'm going to ask is, I live in Plano, Texas, and I'm going to get a response from the large language model. So it now responds with saying, hey, Plano is a nice city, all that. So that's great. Now let's go ahead and say my flight is at 10 p.m. Let's see what it comes back with. So it says, okay, what's your destination? Okay, nice smart question. So now I'm going to ask a question, which is the nearest airport, and when should I start from here to get my flight? Now, clearly in this question, I have not given where I live. I have not indicated what time is my flight. And so let's see if it's able to use the prior information and respond. And there it is. It says that if your flight is at 10 p.m., you should start driving at least 2 hours before, which is 8 p.m., which is a good response. And it knows that I live in Plano, Texas. So Dallas-Fort Worth is the nearest airport. So all good. So this is how you want to use memory along with the large language model to be able to get much better response from the large language model. I hope this helps clarify.
Excellent. So now we'll move on to the third demo, and I'll take a quick time check and want to check Lauren, Gopala, anything you want to add on this?
I'll go for me.
Awesome.
Yeah, I think one question we did have, I think before hopping to the last demo, is just around where these resources are stored. Will they be moving to a Google Cloud GitHub repo, or just a general question around access for these resources?
Yeah. So yes, right now with this is on my GitHub account, and we are working to migrating this onto the Google Generative AI broader repo. Yes.
Awesome. And we can provide that update in the community as well once it's updated. All right. And thank you all for your questions and your patience. We just have one more demo that we want to share, and then we'll be sure to dive into your questions. So thanks for your patience. All right.
All right, cool. Let me take this up. So I'm gonna be, discussing how to you build a retrieval augmented generation demo. The first steps, it's quite similar to what Guru showcased. You install and authenticate. You initialize and build the function, which is just the LLM, LLM wrappers. Ingest the data, structure the data, store it in some sort of a vector database, and then that's where most of your stuff in batch happens. And then in the real time, when let's say a user is searching for something, you obtain a user query, which is the blue arrow in the middle, Then you do prompt engineering, which is optional, by the way, though it is highly, highly recommended. You do prompt engineering and you get the data. You hit the vector database to get the results back. You do some sort of a processing at that point, get some model inferencing, get the model response. You can parse it out, and then you finally publish it to the UX user through the UX. Right? The ones which have star are the LangChain components. You can also use custom code, but definitely using LangChain helps you, move at an exponentially faster pace. So if you go to the next slide, we can see the overall high-level architecture, um, which is just one step back. Yeah, this one. Yeah, amazing. So this one is like this one just showcases how the flow works. The user asks a question. You follow the red pipe. It goes to the vector database, figures out which are the most nearest neighbors in terms of the context. It's gonna send it back to the generative AI LLM along with some additional context, additional prompting. You call that prompt engineering, and then you can return it back to the user. This flow which you just saw, this cyclic flow, sort of happens in real time, or near real time rather. But the flow which is at the bottom, which is the document ingesting splitting step, which you see like documents are being splitted, then the input is being ingested and being stored in sort of like an output table, that is your vector database. That's a batch process. Right? So that's all about the architectural design. Let's dive into the demo and let's see how it's built. Let's go to the next slide. Ooh, let's play the video. Cool. So yeah, this is the demo notebook which showcases how RAG works. That's retrieval augmented generation. The first step, as usual, is almost always to just um, you know get the installed dependencies and all that stuff. So for example, we are going to install LangChain Unstructured, which is just the extended version of LangChain, Google Cloud AI platform to get the Vertex AI and PaLM APIs ready. Chroma DB is our database of choice. That's a vector database, and Gradio is for the UI UX part. We can have a lot of options for vector database, but for this demo, we are going ahead with the open source option, which is Chroma DB. All right, so we'll wait for these dependencies to be installed.
Yeah, one thing is, the Chroma DB is, it's an open source tool. But if you're looking for something like scalability and performance, you know, within the Google Cloud, we have something called a matching engine that can also be used.
Yeah, absolutely. We have the matching engine, which is now Vertex AI search, vector search. We can use that definitely. Right now, as you can see in the next couple of the next cell, we are getting all these instantiating all the LangChain libraries. That's the Vertex AI ones. SDK. It's basically an instantiation step. Following which we will provide the project, the Google Cloud project, and the location where we want to do this experiment in. We want to build our first app in. And then after that, we are using one of the imported libraries that we imported modules from LangChain. That's the GCS directory loader. GCS is Google Cloud Storage. Essentially, this is going to help us load all of our documents from the provided bucket. So the bucket you can see I've provided is, you can see the name. And if you want to see what the content is, this is the content in the bucket. So these are all text documents. It has like a bunch of text documents stored in this bucket. The beauty of LangChain is that it's a very modular code, like we discussed time and again. We just provide the GCS bucket location, and it's going to go ahead and retrieve all the documents from that. It's going to load all the documents from that. Yeah. So this is the step. And then, yeah, the next step is the next cell, which is the LangChain text splitter. So essentially, large language models have a cap on how many characters or how many tokens can be input. So we're going to split the texts because these text files may have bigger text. So we're going to split it to a size of 1000. This will help us reduce the footprint of each individual text file. And we're going to do a chunk overlap of 100 so that the running context, it's like a running window, it's not lost. And if we run this, we get the total number of documents is around 2149. So these documents are basically pre-processed, or I'd say like post-processed text files, right? And the next logical step is to create an embedding. So we're again going to use the LangChain's inbuilt module with Vertex AI embeddings. Then we're going to specify the requests per minute. That is 590 in our case. The upper limit is 600 as of today, right? We will use the text embedding gecko model. As you can see, you can specify multilingual gecko as well. There are a couple of other models as well. Depending on your use case, you can specify that model. For us, it's only English, so we're going to specify the text embedding gecko model. All right. Yeah, and then we're going to create the chroma DB. We're going to fill it up with all the documents that we specified, and we're going to use the embedding vector that we just specified in the previous step. It's going to take a while to do. This step takes care of creating vectors and storing it as against the indexed document. Remember, document here is the post-processed document, not the initial text files, right? Because text files are too heavy to be dealt in one go. So you sort of chunk them out and then create a document out of it. So that's the step. Yeah. Sorry, Vijay. Sorry, go ahead, Guru.
Yeah, if user experience is a concern, then you want to look at tools like matching engine, which really allows you to build your data structure ahead of time, and your index endpoint is ready, and it will really allow you to give some quicker response to your end users. So yeah,
absolutely. And yeah, the next step is just to create a retriever. We're going to put the search type as similarity, which is the cosine similarity, and the search keywords, the arguments is k, which means 2. That means we're going to go ahead and return the top 2 closest neighbors, which is also a modifiable parameter. So depending on the use case, we can increase or decrease it, right? And the final step is to create a QA, retrieval QA, which is also a part of a chain, like I discussed. And we're going to specify the model as text Python 32K. And we're going to run this chain. Eventually, it will be able to answer our questions accordingly. So yeah, this is the way to sort of instantiate the retrieval Q&A, so that we can do question answer type of question type of LLM usage with this model that we just built, rather the chain that we just built. Right. So let's run that, and yeah. So you can see, right, the next cell rather, is to ask the query, because this is based on a legal contract. The question is a little legal. It's like who all entered into agreement with Sagebrush, and we will run this cell, and eventually we'll get all the response, which not just the response, but we'll also get the document to which this response was populated from, sort of like sources or citations. We'll get all that information, and we'll get a couple of other information as well, like which is the GCS path, so you can directly link it to that, and you can eventually quickly iterate and figure out where the source of truth lies, and all those information. So you can see it's quite straightforward, and similar to what Guru showcased, we can build a front end. This is again optional, though it's highly recommended to showcase the snazzy app that you build. You will really, it's a way to quickly iterate and visualize the stuff. Same things, we can ask the similar questions. Who are the parties in ADMA, and we will see not to get the response, we'll get the URL where it's stored, and also the GCS storage URI, so we can integrate it with the larger application. All right, so yeah, seems like it's working fine to me. Okay.
so that's how you want to do retrieval augmented generation.
Yeah.
I think we can now turn it over to the Q&A. And
oh yeah, let's move to that, because in the interest of time.
Amazing. All right. Thank you so much for that information and the demos. It was definitely great to see. And thank you all for your patience and your questions. We will spend the rest of the time addressing your questions. So thank you for those. We're going to dive right in. And if you do need to drop, you can always check out the recording afterwards. So please keep that in mind, and you can watch from the same link that you're using now. All right, so let's dive in. Our first question is, how can you use LangChain to connect Vertex AI Chat Bison to Dialogflow CX? The objective is to create a speech-to-text and text-to-speech chatbot that can have a natural language conversation.
Sure, I can take a stab at that, and then I'll turn it over to Gopala. So the Dialogflow CX inherently is integrated with with the foundational model on the back end, and the Dialogflow CX also provides frameworks within its own a solution set, which is like you have playbooks that you can use, which kind of does some helps in orchestration. You wouldn't really need to use LangChain if you're planning to use Dialogflow CX, because the agent, let's say you want to access a data store, let's say you want to run a Google search, or let's say you want to run an API. The playbook provides you the tools necessary, and it's a very language. I mean, it's just like a human language. You write the playbook, and then the Dialogflow CX uses the playbook to execute. It's an even more advanced way of orchestrating your interactions with your end user. So I really found it very powerful. I don't know, Gopala, what do you think?
Absolutely, it's super intuitive, and like you mentioned, you can use natural language to create to build your entire workflows. And if in case you want to go ahead and if you want to read more about it, you can definitely read about Vertex AI search and conversation, which essentially is linked to Dialogflow CX.
Perfect. And we have just dropped a link to Vertex AI search and conversation into the chat, so you can have that as a quick reference. All right, moving along. Other than an extended Postgres Cloud SQL database, what other managed services will Google offer to create vector stores?
So if you want to create a vector store, or a great resource is matching engine. You could use the matching engine to build your vector store, and use indexes on top. Um, I'm not very sure about BigQuery. I don't know, Gopala, are there other vector stores that are available through Google Cloud?
Yeah, I mean, primarily it's matching engine, which has now been renamed to Vertex AI Vector Search. It's super powerful, and I mean, it's my DB of choice whenever I build something which requires me to have a matching engine. BigQuery, not so much, because BigQuery is it's like a data warehouse. So I would definitely recommend to go with Vertex AI Vector Search.
Awesome. Great, appreciate that. Thanks for this question. Is there a Google native way to integrate external documents into a Q&A pipeline to build a RAG application?
Yeah, I think the data store, the Vertex AI search and conversation that Gopala just referred to, is a great way to integrate external documents, whether it is your your product documents, or whether it is your contracts, or whatever kind of documents. Build the data store, and then you have agents from Dialogflow CX available that will allow you to build great interactive applications for your end users.
Fantastic. And along the similar lines, how can you execute RAG using SQL chain for structured databases, JSON, etc., and get accurate results? Any thoughts there?
Go ahead, Gopala.
Sure. So if you want to use RAG for SQL chain, you can do it. If you have a great database which uses a lot of intense, SQL queries, or NoSQL queries for, let's say, JSON or stuff like that, you can use that database as your source, source database or source repository of code, and then you can create a SQL, like an agent on top of it, so that you can use the RAG approach and get the final output. In fact, we've tried it out, and it really works well in certain cases, especially if the code is well written. It works really well.
And I also want to kind of point you to another tool that LangChain has. If you, let's say, if some of your data is sitting on a graph database, LangChain also has connectors to graph databases that you can use to augment your response. So yeah, LangChain does provide a variety of tools that you can use for enhancing your experience for your end users.
Great. Okay, just a few more here. Chunk size and overlap seem to be arbitrary and require a scientific method to discover the appropriate values. Can Google provide advice to help narrow down the search for these values?
Yeah, it's a great question. I think it's a very good point, Greg, what you brought up. And I am not aware of a scientific method for defining that yet, but definitely it's an opportunity to kind of do some analysis, and we will come back to the community on this. Gopal, what do you think?
Absolutely. I would say it's highly dependent on your use case. If you have a use case where you need to preserve the fidelity of the entire document, then you just cannot. Then it has to be very specific. The overlap has to be almost 100%, and the chunk size also needs to be 100% the size of the document. So I would say it's 100% depending on your use case. It's not, if it's arbitrary if we think of it as a siloed use case, but if you think of it the broad use case, it's definitely more leaning towards what you want to do with it.
Great. Well, thank you for the question. We always appreciate that and different ways and different resources that we can help to provide. So I appreciate that question. Okay. Does Vertex Search and Conversation use ChromaDB in the back end? Any reasons for this choice except open source?
You know, we use ChromaDB in this illustration just to illustrate it. Tools like ChromaDB, which is open source, are very quick to use. So from a pure demonstration purposes, it makes it very easy. But if your intention is, I want to really have a much better experience, without much of a latency, or if you have tons of documents and you really want an enterprise ready, I would gravitate more towards matching engine, so that you're able to build the scale, get the performance. Yeah, just for the purpose of illustration, we use ChromaDB, but yes, you can use vector stores with other vector stores as well.
Great. Okay, we have time just for 3 more questions. So if there are those that we are not able to get to, please use the Google Cloud community, and there's a specific AI ML forum that you can use as well, where the team and community members will be happy to help you out. Okay, so just 3 more here. Does Vertex AI have the ability to perform function calling using LangChain?
Gopal, do you want to take this?
Sure. So Vertex AI, it has its own set of integrations with the LangChain, which you just saw in the demo. To that extent, yes, you can use Vertex AI's APIs, PaLM APIs rather, to call large language models along with LangChain. We do have that. Guru, you want to add something?
Yeah, no, I think you got it. Yeah, absolutely.
Okay, awesome. Would you have a Python or notebook example of using LangChain on a Vertex AI vector search index endpoint within a VPC? What they're seeing in the documentation is using gRPC low-level calls only.
So within the code sample, we have one code sample which accesses the matching engine, uses matching engine indexes as an endpoint, and that's within the VPC. I'm not sure I understand the question. I mean, we have an example available. I don't know if there is anything else that Ludovic is looking for.
If you have any additional context for this question, we'd be happy to see it, especially if you want to drop it into the community. That way we can have a little bit more time and context for your question, and hopefully help provide some resources that will be helpful for you. Okay. Our last question for today is, how can I extract structured data from a PDF and store it into a graph database to generate graphs and do Q&A? Any thoughts?
Yeah, I can take a stab and then I'll turn it over to Gopala. Yes, we can. So the large language model can definitely consume unstructured data, which is in a PDF, and then to be able to capture a structured data within a PDF, you might have to do a little bit of, it depends on the kind of data you have. Some data might be a lot more easier, to be able to query and then pull attributes against it and then build a graph database. but some data might not be, right? We've been able to build graph databases, and then use querying on top of it. And we've been able to query against a document using the power of LLM, and then kind of extract attributes, information, to combine the two. It depends on the document. Yes, you can do for certain types of documents, which are a little bit amenable, which are easy to kind of convert and define attributes, and it depends on the complexity of the data that you're looking at. Yes, it is doable, but is it doable across the board? Some documents may not be possible, some documents, yes. What do you think, Gopala?
Yeah, absolutely. I think, yeah, you can definitely do it from PDF. If you have those sort of legible documents, you can do an OCR, or you can directly parse it. And interestingly, LangChain does provide support to build graph database, and you can query them as well. Like Neo4j is an example. I've worked on it. Neo4j does have its own sort of connectors with LangChain, so you can create a Neo4j QA chain with LangChain. So definitely, if you're able to solve the first part of this problem, second part is sort of already solved for you.
Yes.
Makes sense. All right. Well, thank you, everyone. We are over time, so I appreciate Guru and Gopala for staying on with us and to help answer some of these questions. I know that there were a couple maybe that we weren't able to get to. So again, please, we encourage you to use the Google Cloud community, and you can even tag me in there, and we'll help make sure that you're getting answers from the right folks. So thanks for your time and your patience. I'm just pulling up a few additional resources and next steps for you. So if you have additional interest in these events and different topics, then we would love to see you there. I know I saw a question around AI ops. We have an ML ops session next week that might be useful for you. And then if you have any additional thoughts, suggestions for future topics or sessions, we'd love to hear from you with that feedback form, which has also been dropped into the chat. All right. With that, thank you so much again, Guru and Gopala, for this session. Do you have any final thoughts or recommendations before we close out today?
Happy building apps. Go.
Yes.
luck.
Happy creating, and please feel free to use the community as a resource to share your wins where you're getting stuck, and we'd be happy to help you out. Thank you so much again, everyone, for joining us, and we hope you have a great rest of your day, evening, or wherever you are in the world. Thank you so much.
Thank you. Bye-bye.